This totally changes the game for how companies can interact with geospatial data over cities. We're being told by customers that we're the only network in the world that can produce standardized drone quality imagery over urban areas at any kind of scale.
We have Google Maps, Google Earth that rely heavily on satellites and decentralized update cycles.
There's really three layers of Earth imagery. You have the satellite layer, then you have the plane layer, and then you have drones. And drones have been around for, 10 years plus. But until our network, there's not been an effort to standardize and coordinate the drone layer.
Does that mean that anyone with the right drone and the app can become part of the network?
The only thing that pilots need to be aware of is that
better aerial imagery is becoming increasingly important. I've read that Layered Drone is working on an open shared network of ultra high resolution imagery where drone pilots can earn by contributing data. Hi, I'm Dr. Lorena Nessi for CCN, and today I'm joined by Alec Wilson, Chief Operating Officer at Spexy, founder of Layered Drone. We'll discuss the launch of the Layered Drone Foundation and how decentralized physical infrastructure networks, or DPINs, fit within mapping and physical world data infrastructure using drones. Hi, Alec. Thanks for joining us today at CCN. Welcome.
Thank you very much for having me, and nice to be with you, Lorena.
I'm very excited about learning everything about Layered Drone. So we're going to start with the basics, and I'd like to ask you in practical terms, how does the network work day to day?
For sure. So basically, we at the highest level incentivize people that own their own drones to contribute data to our network, and then the network sells that data to customers that want to buy it. And so there's a mobile application that we've built that the drone pilots simply need to download that connects to their off-the-shelf drones that they already own, specifically the DJI Mini series, Mini 2, 3, 4, and hopefully soon to be 5. And that's the most prolific drone in the world. There's millions and millions and millions of them across the world, many in the United States and in Canada already, and around the world in Europe and in the Southern Hemisphere. We standardize the way that those drones fly. So you can imagine a city, and there's many cities on our network. Overlaying the city is a grid of hexagons. We call them spexagons because they contain flight plan data. The drone pilots simply need to get close to one of these hexagons that they can see in the mobile app. They turn on their drone, they connect their controller with the mobile app connected to that, and they hit the fly button, and the drone lifts off from the ground, totally autopilot, fully autonomous, and it figures out where it needs to get to in this hex, and then it starts imaging this hex in a very standardized, autonomous way. And so this controls the imagery that comes into the network. So the pilots really aren't doing much flying. They're monitoring the airspace for safety to ensure that things go well. And should they need to take control of the drone manually, they absolutely can do that and pause everything whenever they need to. But for the most part, 99% of the operations that exist on our network are fully autonomous. And it takes about 7 minutes for the pilot to complete one of these hexes. They're about 25 acres in size. And then they go to the next one, and the next one, and the next one, and the next one, and the next one. And
the next one, what? The next pilot, or the next?
The next hex in that covers the city. So you can imagine a city like Los Angeles. Mm-hmm. It probably has about 3,000 of these hexes that would cover it. And so the pilots need to start working away and chipping away at all of these hexes and imaging them one by one by one by one. And a group of only about 10 pilots can image a city like Los Angeles in a matter of weeks.
Really?
And so what this produces is the highest resolution base layer of Earth that's ever existed before. So at about 1 inch resolution per pixel, or 2.8 centimeters of image resolution, which is about 10 times as good as the best satellite data that you can possibly buy. This totally changes the game for how companies can interact with geospatial data over cities. And specifically, companies that are looking at this next generation of physical AI. I'm sure you've heard about large geospatial models or world models, and there's been a bunch of big announcements and raises recently for teams that are going after this problem space, which is AI that needs to understand the physical world. Our data forms a foundational component to this next thesis in AI. In fact, we're being told by customers that we're the only network in the world that can produce standardized drone quality imagery over urban areas at any kind of scale. And so we're kind of experiencing a bit of a data arms race for companies that want to get access to it, and we're still the only network in the world that produces it. So um, basically, drone pilots earn each time they complete one of these hexes. They earn per hex, hex per hex per hex. It takes about 7 minutes, as I said, and that data is then sent up into the network, and then is made available to customers that want to buy it through our system. So it's really quite simple. The drone pilots contribute data, and the customers consume it, and that's how the economy works.
Great. Okay, we're going to go into these elements little by little. So let's start, let's say, with the obvious comparison, right? We have Google Maps, Google Earth that rely heavily on satellites and decentralized update cycles. So what limitations do those systems face that low altitude drone imagery can realistically address, or how do they do it differently?
Yeah, so there's really three layers of Earth imagery. You have the satellite layer, which has been around since the 60s. You know, post World War, realized that we needed much more data of the Earth. Satellites started getting launched, but in and around the same time, and around World War II, you had planes that were also imaging the Earth, and that's really what was imaging the Earth before satellites. And planes still very much exist today. And so satellites are imaging the Earth at about 30 centimeters per pixel. Then you have the plane layer, which are aircraft that fly over most of the world's biggest cities every year to image them in higher resolution than satellites. And then you have drones. And drones have been around for, 10 years plus. But until our network, there's not been an effort to standardize and coordinate the drone layer. And so what you get with that is a much higher resolution version of what satellites or planes can produce. So Google Maps, Google Earth, Apple Maps, the big mapping companies in the world, they're all after better data and they want more detail. And so our data provides that resolution. But what they also want, which is critical, is fresher data. They want a more recent view of the world, and they often don't want to have to pay for large areas if they don't need it. And Google Maps and Apple Maps, and these are just one subset of customers. Logistics companies are a big one. Last mile delivery companies, they need really good understanding of how the world's changing so they can more efficiently deliver. Insurance companies, huge buyer of this data, right? They want to understand how the world's changing so they can better use their capital to insure assets or not. We have real estate companies that are all over this. We have like I said, physical AI companies that are just going nuts for wanting better detail of this data. And so it's the resolution, but it's also really the ability to update this data. And what's unique about our system is you don't have to update the whole city, right? You can update just one 25-acre hex at a time. And that's really unique and a big value proposition to customers, because traditionally they've only been able to basically buy big chunks of data, because that's how those business models work. They have to capture a lot at one time. And so they have to sell a lot in order for it to make sense. In our network, you can buy as little as 25 acres of data, and you can update it too. You can tell the network, hey, I want this hex, and this hex to be updated. And a pilot will just go do it because they're already out there. And that's this decentralized model of capture that totally changes how the world will consume data in the future.
Absolutely. But if I understand, well, I mean, if I want to understand actually properly, what does actually ensure the consistent quality of the data? Is it the app? Is it the drone? Can I do it with any drone and then download the app?
So the first thing is the software. So we produce the mobile application and the software that flies the drones using autonomous autopilot flight plans. So the flight plans, the path that the drone flies, and where the drone takes the images and at which altitudes is totally pre-programmed by our software. So there's no room for error for the pilots to go and try to figure out where they need to take images. They don't have to worry about any of that. They simply just need to monitor the system for safety. So if there's like a crane that has recently been stood up for construction that our systems couldn't see before, they would be like, hey guys, there's a crane in this one. we need to come back and do this later. And, we could flag that. And that's part of what the pilots do. They're also monitoring the airspace for other aircraft and things like that. But the quality of the data really starts first from the standardization of the flight plans, which is the software. This is a really important point because I think we've seen other attempts at this from a drone perspective,
Yeah.
not many, but a few. And one of the things that we believe that they all miss is that they're not controlling the actual inputs. They're not controlling their own software. They're using other people's software, and it gets really difficult. So that's one of the main things. And it's basically one of the key reasons that we're able to get this far and sell so much data. The
Mm-hmm.
second is the drones. We standardize also on drone type. So right now, the only drones that are available to be flown on the network are drones that are very light. They're sub 250 gram drones. This is a very small drone, the smallest commercially viable drone you can possibly get your hands on.
Okay.
And that's a really important thing because in many countries around the world, they are awarded with less regulatory scrutiny because they're so light. So they introduce less risk into the airspace, which is really helpful when you're trying to fly over cities because that can be a complicated place to fly a drone.
Mm-hmm.
But also they are so light that when they get to the altitude, which is about 80 meters or 260 feet above ground, when they go image this hex, you can't really hear them and you can't see them. They're very hard to spot and you basically can't hear them because they're so light. And so that means that people that are on the ground that might be looking, hey, there's a drone up there, what's it doing? They actually don't realize that there's a drone up there. And what we don't realize, I think, mostly as humans on Earth is that we're being imaged constantly by satellites. And we don't hear them, we don't see them, so we really don't think about it much. But the reality is that the Earth is being imaged all the time, and we're just providing a much better version of that data. And it's helpful for the entire operation when the drones are out of sight and out of mind. So those two things, software and the drones, play a really important part to the quality of the data.
Brilliant. Well, that takes me to a question you also touched on that I think it's very important and has to do with AI or spatial AI. Because layered drone, as you said, position its imagery as a training data for AI, right? Similar to large language models rely on text, this system relies on this imagery data. So how is this data actually used in practice? And what makes it especially valuable for these systems? How does that work in simple terms?
So we're still early. Sort of the world model, physical AI, large geospatial model thesis is really only about a year old. And so we're learning a lot from these companies as to like what they need. But what we've discovered is that the detail, the resolution of the imagery that's currently available for them to train on, be it from satellites or planes, is not sufficient for the types of world models or physical AI models that these companies need and want to build. So they're looking for much better resolution imagery options. And the only way to get that right now is with drones. Planes just can't produce it at any kind of scale, and satellites can't either. And so then the problem becomes, well, how do you get a lot of quality drone data? And when I say quality drone data, I mean standardized. Because if you have drone data that's different in all different parts of the world, because it's different drones, they're flying at different altitudes, the imagery is different resolutions, because resolution is often a function of altitude and sensor type. That changes kind of how much detail there is on the ground for each image. You get this hodgepodge of data, which is really difficult to train on. Our data is the same everywhere. So whether you buy it in Rio de Janeiro, LA, Toronto, London, it's the same. It's exactly the same resolution. It looks the same, just like how you'd expect satellite imagery to look the same no matter where you bought it from. This is a game changer. No one's ever done that before. And our system is the only in the world that can produce that at scale. And so that's what they want to train on. They want to use that very standardized, really high quality data to build these very high resolution world models to start predicting what the world might do in the future, but really to start tying down in very high accuracy as well. So there's resolution and there's accuracy. So the data has to be very accurate to where it actually is in the world. This enables them to build models that they can start getting robots to talk to. And when the robots talk to this data, whether it be humanoid robots, whether it be cars, whether it be delivery robots, whether it be flying robots, you name it, they all need to really have a good mental map, if you will, of the Earth in high resolution and in high accuracy so that they can start making decisions about it. And just like how LLMs can be, the saying is LLMs are book smart, but they're not street smart. This concept of making AI street smart so that robots can actually plug into it and not do things that you wouldn't want robots doing in the physical world, like driving off a cliff or turning into a wall because their map in their brain isn't fully accurate. That's what's being built, and our data is forming this foundation layer for that. And this was a thesis we had since we started building this, although it really hasn't been. It's really only been in the last 12 months that it's really become much clearer as to how this is going to go. And I think for us, it was good timing. We timed it right. And also we had good intuition there, but some of that's luck too. It just kind of came into this world of physical AI, and we find ourselves authentically sitting in a really good spot for it.
Absolutely. Well, that takes us also to an ethical concern. I cannot, avoid asking you about that. Concerns about privacy or consent or misuse. What ethical boundaries guide what can be captured, stored, shared on the network? What are the regulations? You're capturing the data all around the world. So how does that work?
Yeah, good question. We get it all the time. So I think first, one of the pioneers of this was Google Street View, right? So Google started capturing street level high resolution data all around the world. And I think a lot of the privacy concerns started to bubble up then. It was like, hey, well, this data is so high resolution at street level, like anyone could start using this to, for whatever purpose they wanted. And so Google started coming up with a lot of things that they would do to make the data safer, like blurring faces and license plates and things like that. And our data is inherently privacy protected in that way that it's just at a low enough resolution that you can't see faces or license plates, but it's high enough resolution that it's really valuable to a lot of customers. So there's this, and we have the ability to blur things should we need to, but we haven't found that we've needed to yet. So there's protections in place right at the resolution level for privacy, personally identifiable information. But the second is that, again, the Earth imaging space is not new. It's been around for, 75 years. And there's a lot of protections in place already as to how aircraft can move about airspace in order to image things. And drones are just aircraft. They're really from the eyes of the regulator, and wherever you are, whether it's EASA, Transport Canada, the FAA, they treat drones very similar to how they treat aircraft. And so as long as pilots are flying with those rules in mind and they're following air regulations, they're really able to do a lot of things. And air regulations also take into account places that drones or aircraft shouldn't be flown. And so restricted airspace is something that the network simply just does not have hexes in. And so that's over military installations, over environmentally sensitive areas, over prisons, over government sensitive areas, over you name it. There can be many different kinds of designations for restricted airspace that are published in airspace charts. And we follow all of those, right? The network just does not enable flight in those places. And so that's like one of the core principles is if a plane can't fly there, then neither are we. And so it all grounds to this concept of aviation, which is where I come from. I'm actually a commercial helicopter pilot. That's how I got into all of this, this craziness. And my flight helmet's just behind me there, that I've flown many hours in. And so I know how to read those charts, and our team are very versed in aviation and how, the unmanned aircraft mix into the manned aircraft world. And so there's many things we can do just off the hop to make sure that privacy is protected and drones aren't flying where they shouldn't be. The same includes too close to airports and things like that. Like, there's many things that you just don't want drones doing.
Sure.
But ultimately, I will admit we are pushing boundaries. This network is one of a kind. It's the first of its kind, and it will come up to some resistance in some places, and privacy rules do differ around the world. However, so far we found that we're the largest now standardized for an imagery network in the world. We've flown over 5.5 million acres in North America alone. Almost 200,000 of these hexes have been captured by pilots so far in the last 12 months, and sorry, the last 18 months, and maybe 0.01 of those flights have come up with some kind of issue around privacy or the public having an issue with things. And so we've been very pleasantly surprised in the amount of acceptance that people have when it comes to flying drones.
Brilliant. Well, that takes me now to the question that needs to be asked about blockchain. So this layer drone project or system that you are getting in place that seems super amazing actually uses blockchain-based mechanisms, as I understand, proof of capture and NFTs that function as flight receipts. Is that correct? How do these tools verify that a pilot was physically present at a location, or do they? And why does that level of verification matter for trust in data? And what's the precise role of these tools?
Yeah, so Layer Drone is the protocol that defines and organizes and incentivizes all of this activity. And so the first thing we have to figure out is, okay, well, how do you ensure that the data that pilots are uploading is authentic and that it's not spoofed? Because we're rewarding for this data. And so for the economy to work, everyone needs to trust that the data is in fact authentic and not spoofed. And it's actually very easy to spoof imagery data. You can take an image, go into that image metadata, edit fields in it, re-upload it, and you can trick systems in. It's actually not very hard to do that. And so as we're a blockchain project and we're going to be incentivizing using cryptoeconomics in the not too distant future, we've built a system that authenticates that data using the blockchain. And so our system is fairly simple. When a pilot flies one of these hexes, they hit the fly button, the drone takes off and starts imaging the hex. As soon as they hit that fly button, we mint a Soulbound NFT. The network mints a Soulbound NFT attached to that pilot's wallet. And when the flight finishes, a bunch of metadata is created about that flight. And I can't get into the specifics of all the metadata, but it's a lot of data around the flight itself, where the drone was, what it was doing.
Mm-hmm.
That gets basically related to that NFT right at that time. And this is what we call proof of capture. And so when the pilot goes to upload their data into the network after their flying day, the metadata in the images that they upload, we run that against all of the Soulbound NFTs that pilot created that day. And if the metadata from the images matches what's in the NFTs, we reward them. If it doesn't, we reject the data. And because you can't mess with these NFTs, it's impossible. They're on the blockchain, they're non-fungible. And so NFT, right? Non-fungible token. And so it is working very well. We've not had anyone be able to spoof it yet. So that's how we authenticate the data. And then we are building the protocol to incentivize the capture of this data using cryptoeconomics. So pilots will start earning tokens soon for the capture of their data. Right now, we pay them all in cash. In fact, we're actually going to do a fairly novel I think, way to launch this network, which we'll be able to talk about soon, but I can give you a hint. We're actually going to roll it out a little bit slower than other networks. And so we'll be right now we're in cash. We're going to continue that modality on chain using stables. And then we're going to start rolling out the token in a more gradual way. And that's going to be, we think, really beneficial for our community and for the reliability of the network as it captures data. And so the network also, the protocol, Layer Drone, also houses all of this data. The protocol owns all the data that's captured. And so all the token holders own parts of the data because they own part of the network. And customers have to get access to the data. And so the way they do that is they pay using the native token. And so customers need to simply have that token, pay for the data in token, and then they get access to the data. They don't own the data, they license the data.
Does that mean that anyone with the right drone and the app can become part of the network? And if so, didn't you say that you needed not so many pilots to map one whole city?
Yes, it is a permissionless network, and it's an open network, so anyone can join and contribute. Um, the only the only thing that pilots need to be aware of is that licensing regimes differ for drone pilots depending on the country that you're in, and so if you're in Canada, for example, you actually don't need a drone pilot license to fly on this network because the rules there don't require you to for this
Wow.
kind of drone. In the United States, you do need a license to fly on the network for this kind of drone. In Europe, it depends where you are. You don't typically need a true drone pilot license to fly using these kinds of drones. And so pilots need to be mindful of that because it's absolutely in everyone's best interest that we have safe and effective operations, and that requires licenses in some places. We encourage licensing everywhere, by the way, whether it's required or not. More education is better. We want safe operations on this network.
Okay.
But ultimately, yes, if you have the right kind of drone, you can download the app and get going. And so that's a big part of it. It's really simple for people to get involved and start flying.
Brilliant. So it doesn't matter that you need a few people, relatively speaking, to map a city, because you're always going to need more data anyway, because the landscape is always changing. Is that right?
Yeah, I mean, in crypto, you definitely want to have a bigger community. It's better for the protocol and for everything to just have more people involved. But for us, it's not like we don't need everybody, and we don't need to be everywhere all at once. Like I think one of the challenges that these kinds of networks in crypto has faced is that they've been everywhere right from the beginning. So they've incentivized their activity, whether it be data capture or whether it be data broadcasting or whatever it is, Wi-Fi or cellular or what have you. They tried to get a global footprint right away, and what that meant is they had to incentivize that with a lot of their tokens right away. But the challenge with this is that ultimately it's only as good as it is easy to sell, and you have to be able to sell this data in order for the economy to make sense. And it's hard to sell data everywhere all at once. It's hard to do a B2B sale in all countries right away, right? Typically you start in one country where you're from because you have network effects, and then you grow from there, and then you move. And you think about some of the big traditional two-sided networks like Uber and Airbnb. They didn't you know they didn't have drivers or houses in every country in the world in 6 months. They went from country to country as they built their network and their markets. And that's really how we look at this. It's very important that we don't spend that the network doesn't spend too many tokens too quickly, because when tokens go out, they never come back in, and they're extremely valuable. They're very precious things. And so they represent ownership in the network, and to give away or to incentivize away too many too soon without having the business be up and running in the right places, we think is a big mistake. So we are focusing on network effects within North America because that's where we're from, and we want to really have a good, healthy operating network there before we start expanding to too many other countries too quickly. Although it is very much designed to expand to these other countries quickly once we're ready. The network is, location agnostic. You can put these hexes anywhere and they will work, and these drones are everywhere, so that's really helpful. Um,
Yeah.
but ultimately, it is really, a big core thesis of ours is that we don't want to go too quickly and expand too fast. And so, yes, we need pilots, but we don't need them everywhere. And as you mentioned, we don't need hundreds and thousands per city. We only need 10 or 15 per city, and the city will get imaged very quickly.
Okay. Great. Well, thank you, Alex. Is there anything else that you think we should cover before we say goodbye?
No, I mean, I just think that we've been building this thing for 4 years now in crypto, and we're really excited to bring it out to show everyone what we've been working on. A lot of thought has gone into the cryptoeconomics and the way that contributors and that other stakeholders and customers can interact with it, and we think that it's going to really change how some of these networks are built moving forward. And so, please keep your eyes on it. And we're looking forward to sharing more with you guys as we get closer to the launch.
Thank you, Alec, for joining us today. And well, we're going to say goodbye. That was Alec Wilson, and I'm Dr. Lorena Nessi for CCN. Thank you for watching, and see you next time.